All right, hi everybody. Welcome to this section 4.3 video. In this video, we're gonna wrap up our solving constant coefficient differential equations material with solving an initial value problem. So let's check this example out. So solve the IVP. We have y double prime minus 2y prime plus 2y equals 0. And we have two initial conditions, y of 0 equals 5 and y prime of 0 equals 10. So these are my initial conditions. Okay, so the first thing I want to do, this is a constant coefficient dE. I want to just use the auxiliary equation to solve it. So, we have A equal to 1, B equal to -2, and C equal to 1. So when I set up my equation, I get m squared minus 2m plus 1 equals 0. This factors cleanly into m minus 1 times m minus 1. So luckily, no complex roots to use a quadratic formula. And so what I have here is repeated roots, 1 and 1. And so remember that the solution to a repeated root auxiliary equation is y equals c1 e to the x plus, excuse me, c1 m1 x plus c2 x e to the m1 x. And so therefore my solution here is just going to be c1 e to the x, because it's just 1, plus c2 x e to the x. Okay, so that's my solution, but remember, we're asked to solve an initial value problem. So I got to use my initial conditions to figure out what C1 and C2 might be. So let's go ahead and say that. Use initial conditions to find C1 and C2. So let's try that out. So we're going to use our first initial condition, uh, our original y of 0 equals 5, no derivative yet. Use y of 0 equals 5. We're going to plug this into our solution. So it'll be 5 equals C1 e to the 0 plus C2 0 e to the 0. And this works out nicely. That just goes to 0. E to the 0 is 1. So basically, C1 just equals 5. So I got my first constant, and what I want to do is immediately plug in to the solution. So I'm going to plug it right back into my solution. So what I would have is y equals 5 e to the x plus c2 x e to the x. So now I have my new solution to work with. And so I still need to figure out what C2 is. I'm going to use my second initial condition here, but it says y prime, so I got to find the derivative. So I'm going to use y prime of 0 equals 10. In order for me to use this, I got to use the product rule. Remember, product rule is f g prime plus g f prime. I got to use a product rule for this x e to the x. And so what I get is y prime equals 5e to the x. That stays the same. But then it becomes c2 x e to the x plus c2 e to the x. Right? Because we could say, you know, F equals C2x, G equals e to the x. F prime would be C2, G prime would be just e to the x. So F times G prime, then G times F prime. But now we can just plug in our initial condition. So anything times 0 goes away, so this just goes to 0. E to the 0 just goes to 1, and e to the 0 just goes to 1. So what I'm left with is 10 equals 5 plus C2. So C2 equals 5 as well. So that works out nicely. So therefore, my final solution is 5 e to the x plus 5 as well, x e to the x. And that's my solution to the initial value problem. So just to recap a bit, and we know we had a constant coefficient differential equation. And so we knew we needed to use the auxiliary equation, and we found that we have repeated roots. We use the repeated roots formula to get our solution, and then we just use our initial conditions to get C1 and C2 to get to our final answer. Okay, so that's sort of putting it all together and now looking at a specific case, but trying out in real time. So thank you for watching. I'll see you in the next video. Take care.